Let's take a look at some quick Lewis structures. So a couple of things. Let's take a look at this. One's actually carbon tetrachloride. Couple of things when you're doing this, you want to select a central atom. The central atom is always going to be the one by itself. So this way I have 1 carbon and 4 chlorine. So carbon is the central atom. So carbon is the central. And then I'm going to draw bonds to each one of the chlorines. So let's just draw bonds to each one of the chlorines. Couple of things. When you have like something besides hydrogen, we're going to draw like 6 electrons around it. So something like this is going to be called tetrahedral. That's the shape. So that's one of Carbon likes to have 4 bonds. So when the central atom has 4 bonds, we call it a tetrahedral shape. A couple of things about this one right here. I don't want to get so much into electronegativity and stuff like that. But what happens is chlorine is a little bit more electronegative, so it's going to pull the electrons away from chlorine. From carbon, I'm sorry. But they cancel each other out. So this is what they call a nonpolar molecule. And for us, the only thing you really have to know is it's nonpolar. I got a central atom, 4 atoms are the same. It's going to be a nonpolar molecule. Now, if I change this up, let me change this up. Let's make number 2. Let's make this one right here. Carbon, hydrogen, and 3 chlorines. In this case, hydrogen is always going to be a terminal or surrounding atom. It's never going to be the central one. So carbon is going to be the central. And so in this case right here, it's going to look something like this. Still got 4 atoms to the central atom. That determines the geometry. It's going to be tetrahedral. But a couple of things is that one of these is different. So if one of these is different, it's not going to cancel each other out, which means now it's going to be what they call a polar molecule. That's all you have to know. And the only thing polar means, the electrons are not shared evenly. So when we look at stuff like maybe DNA, amino acids, proteins, it becomes important. Polar, nonpolar, etc. The only thing I really want us to know, just to kind of keep it simple, central atom is carbon. All 4 atoms are the same. It's nonpolar. Electrons are distributed evenly in there. If it's not, so one of these is different, it's going to be a polar molecule. Again, carbon is always for us going to be the central atom. Let's continue with this. Let's look at water. Water is a classic one. So again, the atom by itself is a central atom. So in this case, it's going to be oxygen. And so oxygen, if you look at it, it has 6 valence electrons. So let's kind of draw the 6 valence electrons around it. I'm just going to draw it like this. Doesn't make any difference as long as you know it has 1 electron pair and 2 lone electrons. Hydrogen has a lone electron. Simple as that. These lone electrons just kind of hook up. That's all. And so in this case, I'm going to have something like this. A few things. Hydrogen always forms single bonds. That's all you really have to know. So just kind of know the structure for water. Oxygen is more electronegative, so the electron is going to be pulled towards the oxygen end. This is a bent structure. So if it's bent, let's just call it a polar molecule. Again, I'm kind of going through this kind of quickly. We don't have to know a lot about this. Just know that water is bent, know its Lewis structure, and it's going to be polar. Oils are going to be nonpolar. And again, remember, like dissolves like. This is why water and oil don't mix. One is polar, and the other is going to be nonpolar. So again, I want you to know the structure of water, carbon tetrachloride, the CaCl3. Just know the structures and know if it's polar or nonpolar. This one is ammonia and NH3. So again, nitrogen is a central atom. So again, nitrogen has 5 valence electrons, so it's going to look something like this. Hydrogen has 1. these lone electrons always pair up. So the hydrogen is always going to pair up. So you have to know, hydrogen has 1 valence electron, nitrogen has 5, they're going to pair up. We're going to end up with this. You have a structure like this. So this is a central atom. It has 3 bonds and 1 electron pair. So it has 3 bonds, 1, 2, 3, 1 electron pair. Whenever you have that, it's called trigonal pyramidal. Trigonal pyramidal, always going to be polar. So basically, I just want you to know the 4 structures I've done. I didn't go into a lot of details with it, but again, just know that this is going to be a trigonal pyramidal, and it's going to be a polar molecule.